So today we are continuing on with quadrilaterals, and we've got rhombus. Okay, now remember we started with parallelogram, and from parallelogram we have talked about rectangles, which are a type of parallelogram. Okay, and today we're talking about rhombus. Okay, now rhombus is also a type of parallelogram, but it's not necessarily a rectangle. Okay, so we need to make sure that we are mindful of that. Okay, that it's not going to be a rectangle, but it is a parallelogram. Okay, now with parallelograms we had 5 properties. Okay, with rectangles we had 7 properties, and today with rhombus we have 8 properties. Okay, now mine is a little messed up on the screen. This one says 9, it's supposed to say 8. Okay, so 8 different properties that we're talking about. The first 5 are still going to stay the same from what we've done with parallelograms. Okay, so our opposite sides are parallel, our opposite sides are congruent, our opposite angles are congruent, our consecutive angles are supplementary, which means equals 180. And our diagonals still bisect each other. Okay, but now we get to add these 3 other properties that are kind of going to go together with some of those top 5 properties. So property number 6 is that we have 4 congruent sides. Okay, now when we have 4 congruent sides, that means all 4 of my sides are going to be the same length. Okay, so in this case, we're going to have AB is equal to BC, which is equal to CD, which is equal to DA. Now, based off of our top properties, we also know that our opposite sides are parallel still. Okay, and we have opposite sides that are congruent, which is true because we have all 4 sides as congruent. Okay, then we have number 7. Okay, number 7 is a little bit different and is new from anything we've talked about. Okay, so number 7 says diagonals are perpendicular. Now remember, when we have perpendicular segments, that means that we are forming a 90-degree angle. Okay, so our diagonals are AC and BD, and remember that our symbol for perpendicular is this upside down T that forms a right angle. Okay, and we know that that means that we have formed 90-degree angles. Okay, now where do we form those 90-degree angles? Well, it's where our diagonals intersect. Okay, so right here at point E, we're going to have a 90 degree, and all 4 of these angles end up being 90-degree angles. I'm going to fix this one real quick so it looks more like a 90. Okay, so we would have 4 90-degree angles here in the center. Now that's really important because when we have 90 degrees, remember we have special triangles that we use when we have 90 degrees, and we can use Pythagorean theorem and all of that kind of stuff. Okay, now before we talk about number 8, let's backtrack and talk about number 5. Okay, diagonals bisect each other. When we have diagonals that bisect, remember we have 2 equal pieces. Okay, now on rectangles, we knew that the diagonals, the whole diagonals were equal, but here we don't know that they're equal. Okay, here we just know the diagonals bisect. So that means that we're going to have BE is going to be equal to ED, and then AE and CE are going to be equal. Okay, but BE and AE are not equal on this picture. Okay, so we have AE equals EC, and BE equals ED, but AE and BE do not equal each other. So our last property that we have is that the diagonals bisect the opposite angles. Now you'll remember from when we talked before about opposite angles that our opposite angles would be this whole angle A, or we can name it BAD, is congruent to this whole angle C where we have angle BCD. So when we bisect angle A, that means that this side, angle BAE, is equal to this angle, angle DAE. So I'm going to just put an X right there, which means this is X. Okay, now if it bisects that angle, okay, we know the whole angle A is equal to the whole angle C, so that means that these pieces also have to be X so that our opposite angles are equal. The same thing happens with B and D, but they're not going to be equal to the angle A and C, so we're going to just call those Y. So at angle B we would have two angle Y's, and then at angle D we would also have Y and Y, so that those angles are equal. Okay, so remember that our diagonals bisect opposite angles. Okay, so as we continue on, we're going to keep talking about these properties to solve problems. Now, I'm not going to cover everything, okay, but this is a good reference for you to come back to. Okay, now remember we are talking about rhombus. Okay, now you'll also hear this called rhombi sometimes. Rhombi, okay, because that's the plural form of rhombus. Okay, so looking at number 1, angles are going to be very important. Okay, angle ABD is 60. Remember we've got A, we're going to B, and we're ending at D. So this angle is 60 degrees. Okay, they want us to first find the measure of angle BDC, which is this angle. Now those angles are on opposite sides of the diagonal in opposite angles. So we know that the measure of angle BDC is going to equal the same thing as ABD, which means it's 60 degrees. Then it asks us to find the measure of angle ECD. Okay, and ECD is this top angle right here. I'm going to call it X. And to find that angle, we have to look at this as a triangle. Remember that our angle at angle E is a 90-degree angle. If that's 90 and this is our triangle, we know that angle D here and angle C up here add to equal 90, or all three angles add to equal 180. So to find the measure of angle ECD, we could say 60 plus 90 gives us 150, and then we could subtract that from 180 to get 30 degrees. Or you could just say 90 minus 60, which gives us 30. Either way, you get the right answer. Okay, so moving right along to number 2, I put number 6 up here at the top because these are similar problems. Okay, if we know that AE is 8, so this section is 8, and they ask us to find this whole section, AC, then we also know that EC is 8. So here we can say that AC equals 8 plus 8, which is 16. Okay, now that's our basic easy one, just numbers. If you look at number 6, here we know that AE equals 3x minus 1. Okay, then we also now know that AC, the whole thing equals 16. So you have two different options here. If that piece is 3x minus 1, AE is 3x minus 1, then EC would also be 3x minus 1. So you could say 3x minus 1 plus 3x minus 1 equals 16. Now, if AC is the whole thing, you could say AC divided by 2 equals 8. And you could say 3x minus 1 equals 8. Two different options that you have on this type of problem. Okay, either way, here we've got 6x minus 2 equals 16. Okay, we get 6x equals 18, and then divide by 6 and you get x equals 3. You would also end up with x equals 3 if you solved this other one. Okay, you would add 1 to get 9, and then divide by 3, which would give you 3. Okay? So, moving right along. Number 3 is a little bit different. Okay, we are talking about AB equals 26. That is a side length. And BD equals 20. Now, BD is this full diagonal right here. Now, in relationship to the AB, we've got to figure out if that does us any good. What they want us to find is AE, which is this section right here, from here to here. Now, when you look at this, we don't really need that full length of BD, but it would be helpful to know what segment BE equals, and that's going to be 10 because it's half the length of the diagonal. So this piece would be 10, and this piece would be 10. Okay, now remember, here at angle E, we have a right angle, so now we can look at our right triangle. Okay, so on our right triangle, we have 10 at the bottom, x, and our hypotenuse across from the 90 is 26. So if you remember, when we want to find a missing side on a right triangle, we need to use the Pythagorean theorem. So here we have x squared plus 10 squared equals 26 squared. So we've got x squared plus 100 equals 676. Now, we subtract 100, and we get x squared equals 576. When you take the square root of 576, you end up with x equals 24, so AE equals 24. Now, there's a couple different ways to do Pythagorean theorem. You could have said 26 squared minus 10 squared equals x squared. It doesn't matter as long as you're getting to the right answer. This next one involves no work at all. We start at C, we go to E, and we end at B, and we want to know what that angle is. Okay, remember that because our diagonals are perpendicular, then that angle equals 90 degrees, and that's all we've got. It's easy as that on number 4. Okay. So, a couple more problems, that way you can see just a couple more things. Here we've got angle CDB. CDB is this angle is 6y. And ACB, which is going to be this top angle, is 2y plus 10. They want us to find y. Here, we don't have these angles in the same triangle right now. Okay, we do know that right here there's a 90, and right here there's a 90. Okay, so what we've got to look at is what angle is equal to one of these angles so we can find y. If you remember, these 4 angles would all equal the same thing. So if that side is 2y plus 10, then this angle right here also has to be 2y plus 10. So now we have in our same triangle where we can set up our problem. So we have 6y plus 2y plus 10, and remember that those two angles have to equal 90 because our third angle is 90. And then you would just solve, right? 8y plus 10 equals 90, and you would go from there. Okay? Make sure that you're being careful about where your angles are getting labeled. Okay? Then we've got number 8. AD is 2x plus 4. CD is 4x minus 4. And those are sides, and we know in a rhombus that all 4 sides are congruent. So when all 4 sides are congruent, we can set them equal. So we can say 2x plus 4 equals 4x minus 4. And be careful how you solve these, okay? When we subtract 2, we've got 4 left. We've got 2x minus 4. And then we want to add that 4 to both sides, so where we get 2x equals 8. Divide by 2 and we get x equals 4. Now here, though, it asks also for BC. Okay, now remember, all 4 sides are equal, so it doesn't even matter which one you plug it back into. Okay, so 2 times 4 plus 4 is 8 plus 4, which equals 12 units. If you plugged it into the other one, you would get 4 times 4, which is 16. And 16 minus 4 gives you 12 also. So it doesn't matter which way you go. Our last two problems are also talking about angles. We just switch it up here a little bit. If the measure of angle RST, okay, this whole angle is 118, find the measure of angle RSW. So here's RSW, which means we're trying to find this angle. Now if you remember that our diagonals bisect the angle, okay, so to find the measure of angle RSW, we just have to take the whole angle, 118, and divide it by 2, which gives us 59 degrees. So this angle would be 59, this would be 59, this would be 59, and this would also be 59. And our last one, just a tad bit tricky, but using that same idea, is if we have angle, we want to find angle SVT, that angle right there. So this angle is what we're looking for. I'm going to call it X. Okay, they give us angle STV, and my picture is a little bit off. Let's trust the numbers here. Okay, so this whole angle is, I'm going to also change this to a 136, that way we don't get decimals. Okay, so this whole angle is 136. Now again, there's a couple of different ways that we could do this. Okay, I'm going to find the consecutive angles first. So if that's 136, then I can find this angle down here, okay, by subtracting from 180. So first I'm going to find angle TVR and say 180 minus 136, which ends up giving us 44 degrees. Okay, then if this whole angle is 44 degrees, then I know that the diagonal bisects. So to find the measure of angle SVT, I want to take that whole angle and bisect it, okay, cut it in half, so divide by 2, which is going to give me 22 degrees, which would be my answer. Okay, so rhombus can be a little tricky. You've got to use the notes. Make sure that you're referencing the notes. All right?